We're going to be answering this question before us. It says, an experiment consists of drawing a number at random from 1, 2, 3, 4, 5, 6, 7, 8. Let A be this, let B be that, and let C be this. Are A and B independent? Okay, so we have to use our test for independency. So let's begin by finding the probability of A occurring. So that means pulling either 1, 2, 3, 4 out of this. Well, 1, 2, 3, 4. There are 8 in total, so that's a probability of a half. What's the probability of pulling B out? 1, 3, 5, and 7. Well, there's 4 options there again. 4 out of 8 will be a half. The other thing that we need to consider is what the probability of A intersection of B is. To find that, let's find the elements that A and B have in common. So that's going to be, now let's have a look here, 1 and 3. So they have 1 and 3 in common. So that means the possibility of pulling out the probability of A intersection of B would be 1 and 3. So 2 out of 8, which is 1 out of 4. Now we're going to use our test for independence. The probability of A times the probability of B is equal to what? 1/2 times 1/2 is equal to 1/4. And would you look at that? 1/4 is the probability of A intersection of B. So that means, here's the big moment, everyone. This is the big moment. The probability of A times the probability of B is equal to the probability of A intersection of B. Therefore, A and B are independent. Bang. Let's do the other one. Rub this out. Come over here. Are A and C independent? We're going to do the same thing. Fun times. The probability of A is again a half. What's the probability of C? Okay, C is 4, 6, and 8. So obviously 4, 6, and 8, that's going to be 3 out of 8. We also need to figure out what the probability of A intersection of C is. To do that, we need to figure out what elements A and C have in common. Okay, so A and C, what elements do they have in common? They have 4 in common. And that is all. They only have 4 in common. That's pretty boring. So that means the probability of pulling out A intersection of C is just pulling out 4, which is 1 on 8. So now we're going to test the independence by going the probability of A times the probability of C. So that's a half times 3 on 8. And a half times 3 on 8 is going to be 3 on 16. And hopefully you can appreciate that that is not equal to 1 on 8. So in other words, the probability of A times the probability of C is not equal to the probability of A intersection of C. Therefore, A and C are not independent. And that is the thinking behind that question on how to approach it. Hopefully that has made sense on how to use that independence test.